Yo, what's up, our fellow listeners? Welcome back to B-iTalk podcast, where we discuss biomedicines and bioinformatics in a nutshell. Back with me again, finally, on the host seat, Albert. But today, I won't be alone because Jeremy, Daddy, and Karin will be the main hosts also for today's session. Hello, guys. Say
Hi guys,
hi.
nice to meet you all again.
Hi guys. Hi.
Hi.
What are we going to discuss today, Albert?
I heard that Bernard will talk about his specializations, the mighty infectious diseases.
Objection here to say.
Oh my god, I don't think this is a trial. It's a podcast.
Yeah, so, okay, apologies to the rightness, Karin. So yeah, we are discussing infectious diseases and their treatment. Yeah.
So without further ado, let's please welcome our speaker, Bernard Nathaniel from BioMedicine with the specialization in infectious diseases.
Well, hello guys. Thank you for having me today.
Woo! People clap.
So Bernard, how was your day so far?
As usual, I'm doing okay today. And how about you guys?
Truthfully, not so much. But yeah, in general, I think we're doing okay today, right? So, yeah.
Oh, glad to hear that, Albert.
So in order to catch up with
So
our
could you say
discussion, you can listen to our previous podcast in our description box. And now let's start our discussion, and so we can end soon.
Whoa. Really want to end it soon, huh? So, okay. Please allow me to start the discussion. So let's start with something simple, yet an important questions. Which some of our listeners may not know, or majority won't be knowing. Probably this is the first time they heard about these terms. What are the types infectious diseases? What are they?
Okay, Albert. I think that's a very good question. So, infectious disease could be caused by several pathogens, and these pathogens are termed as infectious agents. And
And what are these infectious agents?
It can include the bacteria, the parasites, the fungi, and the viruses. And the parasites themselves are further divided into three categories, which are the protozoan, parasitic worms, and parasitic animals.
Wait a minute. What do you mean with parasitic animals? Can you give us an example of it?
Yes, sorry for the confusion. What I mean with the parasitic animal is that animals that belong to the arthropods. These include the insects, mites, and ticks. This insect could include fleas, flies, and mosquitoes. And not to mention, lice and fleas differ from ticks and mites, but in Bahasa we know them as kutu for all of them.
Ah, yeah, I see. So in Indonesia, we just kind of generalize them without not knowing, right? So, what's the difference between those? Those who I just said, fleas, lice, mosquitoes. What are the differences?
So basically, both of them are ectoparasites or parasites that live on the whole surface. However, the ticks and mites are not insects. Instead, they are acarina, which only have 2 body parts and 4 pairs of legs as opposed to 3 pairs in insects.
Oh, okay.
That's a new insight, at least for me. And what about other agents? Are there any significant differences in terms of signs and symptoms?
Okay, another good question. So basically, they share generalized clinical manifestations such as the fever, diarrhea, fatigue, muscle aches, and coughing. However, it also depends on the agents and the infection sites.
Can you give me some examples?
Oh, sure, Karin. Instead of viruses, it targets specific cells such as the respiratory tract for flu viruses, and so these viruses will cause runny nose and other respiratory specific symptoms. For bacteria infection, the swollen lymph nodes could take place in skin infection that close to the particular glands. Rash could indicate a fungal infection, and at last, the parasite infections, especially intestinal parasites, could cause abdominal pain or cramping.
Okay, I see that. Yeah, that's clear for now. I don't know why did you study this. It's kind of gross, just the way you say it. But yeah, but I want to know how they could transmit it to the human body.
Yeah, sorry for that. I forgot to mention that information before. So it could in several ways, either direct contact or indirect contact, insect bites, and the last one is by ingestion of contaminated food. The direct contact means that the pathogens are transmitted from the infected person to others through touches, kisses, sexual contact, body fluid, and etc. It could also be transmitted through bites from infected animals, such as rabies from the infected dog's bite. And the placenta and breast milk could also be a way for pathogens to enter the unborn baby.
So, Bernard, I wonder how about the indirect one?
So for the indirect transmission, the pathogens are being transmitted from inanimate objects that have been contaminated with the pathogens and enter the body through mucosal membranes such as the eye.
What about the last two transmission methods?
Insect could become the carrier for some pathogens such as the Plasmodium falciparum. The pathogens need insects' help to enter the human body, whilst ingestion, the most common route, is a mode of transmission in which humans unconsciously ingest the contaminated food or water.
Wow. Okay. So yeah, that's clear explanations of infectious agents. But unfortunately, there's a lot of things that I think we need to talk about, and we need to move on to the other topic of the day, which is the diagnosis of those infectious diseases.
I think we should move on to the other topics, which is the involvement of biomedicine in society.
Maybe we can start with their involvement in treating infectious diseases.
Yeah, sure. That is a good topic to start with to discuss. Yeah, because I think people still misunderstand the role of the biomedicines in treating the disease.
Yeah, I think even for myself, I still don't have a clear idea what's the role of biomedicine and how it differs from medical.
Yeah, Bernard, can you share some light to us?
Of course, yeah, that's true. Because both of the fields are overlapping, right? And let me start by telling you the major aspect that differs between both of them. So in the medical field, the doctors directly deal with the patient, such as diagnosing the disease from the symptoms and prescribing the patients with the appropriate medicine to alleviate or even cure the disease. However, in biomedicine field, we don't directly deal with the patients. Instead, we deal directly with the infectious agents that I already mentioned before, and try to elucidate the mechanism of them to cause the disease.
So, after we know the mechanism, how is it useful to treat the diseases?
Because when we know the mechanism, we can try to develop a treatment for sure with a pharmaceutical company, but not by ourselves. That will interfere with the ability of the pathogens to cause disease, such as by limiting the virus' ability to infect the cells.
I see. So basically, you are the one that provides the knowledge to the medical field, and then the medical field is the one that uses those knowledges to treat the patients.
Yeah, that's the main point.
Okay, yeah, I think you already got the point, right? The general idea. So we can session now. No, I'm just kidding. So yeah, we still have a lot of discuss that they need to do.
Yeah, of course, we are nowhere near to the end.
So I'm curious about the diagnosis process of infectious disease, especially from a biomedicine perspective.
Sure, that's also interesting to discuss, but I would say we aren't really involved in the diagnosing process itself.
Wait, what? Really? Because as far as I know, you can do examination techniques to verify the presence of pathogens in a sample, right?
Yeah, of course we do that, Jeremy, but we don't directly deal with the patient sample. I mean, we don't do that for the common diagnosing process, such as the feces routine culture to determine the bacterial types present in one's digestive tract and report it back to the doctors. That's definitely the work of laboratory technicians.
Okay, but I'm still a little bit confused. Can you tell me more on this?
Okay, Jeremy, sure. So, we do the diagnostic test, but not for the routine test, as I said before. For example, we got a request from a doctor to do a diagnostic test for a complicated disease, such as to diagnose a bacterial infection with antibiotic resistance. But the strain is still unknown. So basically, we do the diagnostic test if the doctors require further examination of the sample or the pathogens are simply unknown.
Oh, I see. So you are the one that is doing the experiments to determine the agents in a novel disease.
Yeah, we are the ones doing the jobs to provide knowledge. So don't underestimate us, okay?
Oh, nobody's underestimating anyone, Hesse. So, okay, maybe we can understand this topic by looking at the current pandemic, right? All over around world is a buzz. Everyone's know it, right? The COVID-19. Can we? Yeah.
Okay, how about we start our discussion again?
Okay, sure. I will discuss about the COVID pandemic.
So, Bernard, can you use this pandemic to explain more about your involvement for society? You know.
Okay, I think let's do the COVID crash course, right? But let me think. Where should I start?
Okay, just take your time.
Yeah, or maybe you can start brief explanation about what is COVID-19, right? For those who still don't know in depth, right? Probably most know, but yeah, just to make everyone on the same page. Yeah, so what is COVID-19?
Thanks for helping, Albert. Yeah, as you already know, the COVID-19 is an infectious disease that is caused by the notorious SARS-CoV-2. This virus belongs to the family of coronaviruses, and this family has been widely known to cause diseases in either humans or animals. In humans, it caused the outbreak of SARS and MERS 5 years ago. However, the virus is not the same in other. SARS is caused by the SARS-CoV-1, and MERS is caused by the MERS-CoV. And do you want me to explain the SARS-CoV-2 from the virology perspective?
Yeah, sure. If you can, yeah, but don't need to be too detailed. Otherwise, this podcast will take certainly ages. Yeah. So please, yeah.
Of course, Albert, I'm not the real expert in this because I'm still a student.
Yeah.
Okay, I'll try my best. So, as all you already know, viruses need genetic material, right, to replicate and complete their life cycle. And virus has a type of, and this virus, especially the SARS-CoV-2, has a type of RNA genome type. That's why we need reverse transcription quantitative PCR, PCR, the polymerase chain reaction, to diagnose the COVID-19.
Yeah.
Sorry to interrupt, but why do we need that particular type of PCR to diagnose COVID-19?
As I already mentioned, because this is the RNA type virus, right? So the PCR machine can only detect genetic material in the form of DNA. So reverse transcription is the process of converting the RNA into DNA by the help of reverse transcriptase.
Oh, okay, I see. Please continue.
And for the attachment itself, the virus uses their spike protein on their surface to bind with the ACE2 receptor on the cell surface. I think it's enough from the virology aspect.
But I'm curious, what's your involvement in this pandemic?
Okay, so we are the one that studies the etiology of COVID-19 at first, as well as the mechanism of how this virus can successfully infect the cells, like the ACE2 and spike protein interaction that I mentioned before this.
And then,
as you already know, there is currently no such available potent medicine to treat the disease. But as we already discovered the ACE2 spike interaction, we can use other available medicine that is commonly used for present infection to treat COVID-19. And this medicine called ivermectin is really valuable to shorten the discovery process, since we don't have to make medicine from scratch, right?
Wait. Okay, hold on. Bring it back to one point you say. So, you said we can use parasite to treat COVID-19, right? Can we really use parasite medicines for COVID-19?
Yeah, sure, but in vivo-wise, it can. However, if I'm not mistaken, it's still in the clinical trial phase to ensure that its efficacy is realized.
Okay.
Yeah, I think I know this study, and if you guys are still curious about this, we will talk about it in the subsequent session, where we will discuss the involvement of biomedicine and bioinformatics in society in much more detail.
Yeah. Okay. Nice set, Jeremy. So yeah, it was a really good discussion, guys. Right, we talked a lot about biomedicines in general, how they play a role in society. Right. Let's take example of this COVID-19 pandemic. Sadly, we have come to an end of our sessions from today. It was really good discussion and a lengthy one. I realized that infectious diseases is not a less interesting topic than human biology. Yeah, but even it sounds complicated for me, at least. Yeah.
Okay, so big thank you to Bernard for taking the time to talk with us about this interesting topic.
Mhm.
And that's all today for today's podcast. In our next podcast, we will be talking about bioinformatics and sequencing. Stay tuned for the next session of our podcast. Bye.
Bye. See you guys next time.
Bye, guys.
Bye.